We're going to do says moving counterclockwise. Please write down the words counterclockwise because sometimes that's confusing to students. Moving counterclockwise around a unit circle, in which two quadrants will the value of cosine increase? So moving counterclockwise, when will the value of the cosine of an angle increase? So I think this is easiest to understand by visually drawing a circle. And again, we think of this as like an x and y axis, but in trigonometry, remember, this is cosine and this is sine. So when you think of cosine, you need to think of x values. So here's my starting point. If somebody says counterclockwise, think of this as an analog clock. Analog clocks have the minute hand going this way. Counterclockwise means we go the opposite way. So for us, it's just like normal. We start here and we're going to move upwards. We want to know when are x values increasing. Okay, so x values, please make these lines. X values go from left to right. The further you go to the right, the larger the x values. The further you go to the left, you have more negative values, which are smaller. I wish I could draw. We clearly know at this point I cannot. This is a hot air balloon, okay? And there's people right there inside the hot air balloon. Got it? Okay, good. So here's my question for you. You're in a hot air balloon. As I go around the circle, all I want you to think of is in terms of x values, are the value of x's getting larger or smaller? So here you are, ready? Are the x values, not y, are your x's going towards the large values or small values? Small values because you're headed towards the negatives. So small values right now. What about now? X values, are you headed towards the small negatives or are you headed towards the large positives? Okay. Now, but here there's a turning point. You're like, oh, I'm done going that far. Now I'm going to start going this way. Now, so as I start to go back in this direction, are you now headed towards the larger x values or the smaller x values? Okay. And you're still heading towards the larger x values. So the answer to this is quadrant 3 and quadrant 4. Cosines will increase in quadrants 3 and 4. If I would have asked the question, where are the cosines going to decrease, it would be in quadrants 1 and 2. Okay, draw yourself another picture. If you want to try to replicate my hot air balloon, feel free to. Same type of question. We're moving counterclockwise along a unit circle, and this time I want to know, when will the sine values increase? When will the sine values increase? So sine values, what do we think of? What variable pops into our mind when we think of sines? Okay, so here's my hot air balloon again, and these are the people. Does anybody have a desire to ever go in a hot air balloon? Anybody? 1, 2? All right. Has anybody ever skydive? Okay. All right. Here we go. We're starting here. So think about y values. When are you going up? When are you going down? We're talking about increasing. So when are the y's getting larger? What are we doing right now? We are going up. So are our y's going up? Okay. But now what happens? Now they're going down. Are they still going down? Yes. Are they still going down? But what happens here? They start going. So where do they increase? Quadrants 1 and 4. If you were asked where do sine values decrease, it would be in quadrants 2 and 3. Next unit circle, please. We want to identify in which quadrants can we be guaranteed that all cosine values will be positive. Don't say the answer. I just want you to raise your hand if you know. Where are all cosines positive? 2 people? 3 people? Okay. Luis, are you willing to share? 1 and 4. Because remember, cosines are like x's. CBS, cosine before sine. And where are all sine values positive? All the time. Hands up when you know. Brenda? 1 and 2. Sine value is always positive. Cosine value is always positive. So remember, this is a positive, positive, negative, positive, 2 negatives, and a positive negative. Now tangent means, and remember CBS, cosine before sine. Tangent is sine divided by cosine. So in which two quadrants can you guarantee you'll always have tangent values that are negative? Hands up when you know. In which two quadrants can you guarantee you will always have tangent values that are negative? Santos? 2 and 4. Good. Because positive divided by negative and negative divided by positive will always give you a negative. Likewise, in which two quadrants can we guarantee that the tangent is positive? It would be 1 and 3. Okay? Here's your next one. This is a 30-degree angle. I want to know, in terms of a radian measurement, what would be represented here? Don't say it out loud. Think about it. In terms of a radian measurement. So I'm going to first do degrees. 90 and 90 is 180. 180 and 30 is 210. But remember, we're going backwards, so this is a negative value. But it's said in terms of radian measurement. So what is 210? Remember, you can attach a pi and put it over 180. And then let's reduce it. So 710 divided by 180. Hit math, fraction, enter, enter. We get an answer, just like he said, of 7 pi over 6. If I just write 7 pi over 6, I'm wrong. Why is it wrong? It needs to be negative. Nice job. Okay, here's your next one. All right, hold on one second. Ooh, this is a good one. This is not hard. Please write this down. Find, oh, goodness. 2 more days with you. Not good. I'm close, but I'm female. Okay, find the cotangent of an angle when the cosine of the angle is equal to the negative sine of the angle, and the angle lies in quadrant, hold on, the angle lies in quadrant 4. This actually is really easy. It's the question that makes it sound so difficult. So, in my opinion, you're either going to get this or you're not going to get this in 30 seconds. So do the best you can to come up with an answer, and then we'll go over it together. I'm going to miss you, Isui.
What?
I'm going to miss you.
I'm gonna miss you too.
No, I'll miss you too. I miss everybody. Henry's talking under his breath right now, I can tell. Okay, you ready? Henry, do you have an answer for me?
No.
I believe you. Really? Do you have a clue or no?
No.
Did you try?
Yeah.
Okay, so Henry, you're going to get the answer for us. Henry, did you feel like you understood trigonometry or not, this unit?
Yeah.
Okay, so Henry, you ready? I have 100% confidence if you don't get this right, half the class has to do one push-up. You ready? I have 100% confidence in you. Okay, you ready? So I'm going to guide you through this, but you have to tell me the answer. Where do I find quadrant 4?
On the right bottom.
Okay, good to go. We're done with that piece there. Good so far? What does this mean? This means that, tell me which one of these points that you've memorized are they exactly the same numbers, but the cosine is a positive number and the sine is a negative number. Only Henry can answer.
You mean the 45.
Okay, so tell me what it is then.
So I put 2 over 2, and I put 2 over 2, and then, yeah,
Okay, dang it. Okay, so we're done with that. Now we want to know what is the cotangent. Do you remember how to find cotangent?
it's the inverse of tangent.
Yep. So what is tangent?
It's, adjacent over.
You're close right now. So forget about the words adjacent right now, even though those could guide us. Forget about adjacent or opposites. Do you remember out of sine or cosine, what one goes on top?
I think cosine.
I can't hear you.
Cosine over sine.
I don't think I can hear you.
Said cosine over sine.
I think he said cosine over sine, right. Okay, so this is tangent. So when you do the cotangent, cotangent, just like you said, is going to be the reciprocal, which is cosine over sine. So when you see that you have the exact same numbers, and you take CBS, cosine before sine, you take this value divided by this value. Forget about the positives or negatives. This divided by this is going to give you an answer of 1. And because they're different signs, it's going to be an answer of -1. Henry, did you understand that?
Yeah.
Okay. Does anybody want more time before I move this? I can move it? Okay. These are the problems that you struggle with the most, and I'm not sure it's because you did not prepare for the time of the test, or it's just a concept you did not understand very well. Here we go. I would like you to find the tangent of an angle when the cosine of the angle is -1/4 and the angle lies in quadrant 2. And because of time, it's in our last day, we're gonna take time to do it together. So I'm gonna go to quadrant 2. It's your last day before your test.
What test is Monday?
You only see me Monday and Tuesday, you're done after that.
And what's
Wait,
Tuesday?
what
What
are
do
we
we do
doing
Tuesday?
Tuesday?
You're having a 2-day test because you don't know if the computers are gonna work. Because like Aurelie today, her computer took 20 minutes, 25 minutes just to start up. This morning before class started. It's not Aurelie's fault.
Wait, so we could like do 0 questions?
No,
Monday?
because it's on the computer. Because it's,
But even if you did finish, if you didn't finish it, it's not gonna save.
so my understanding is after you pass 1, I don't think you can go back to 1. Does that make sense to you? Because it's not on paper, so every understand I haven't seen what it looks like. But because it's on the computer, I'm guessing like I've taken math classes before, you have to do 1 before you can go to 2. Does that make sense to you? You do 2 before you go to 3. It's not like the paper test when it was a 2-day test. I know a lot of students would be like, well, I'm going to do all the problems I know how to do today. I'm going to study tonight. I'm going to go back and do those tomorrow. I don't think you have that option because it's a computer test. We're still okay? You understand?
Yeah, I understand.
Okay, here we go. We're in quadrant number 2. Let's draw a line to the origin. Draw a line back being tangent to the x-axis, the cosine. And remember, your central angle is always closest to the origin. Now, I've seen a lot of students when I was grading tests try to put a negative sign along this triangle. That negative is only there because cosine values in this quadrant are negative. So, cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Okay, now I need to find this value right here. So a squared plus b squared equals c squared. B squared equals 16 minus 1. B squared equals 15. And when you saw this algebraic equation, you should get a plus or minus the square root of 15, but because we're talking about length, we only use positive values. And in the past, we've been able to sometimes break down a radical and simplify it. But in this case, we know 4 does not break down 15, and 9 does not break down 15, so we can leave it as is. Okay, so tangent. Tangent is going to be, yes, it is sine divided by cosine, which represents opposite over adjacent. Could you leave it like this? Sure you could. Could you simplify it just to the square root of 15? Absolutely. But either one of those answers alone is wrong. And the reason is, in quadrant 2, what are the tangents? Positive or negative? They're negative because sine and cosine have different answers, or different signs. So either one of these would be totally acceptable. Okay, here's your next problem. Okay, so you're told that the sine is negative 4/5, and that the angle lies between pi and 3 pi over 2. I want to know what is the secant and what is the cosecant. Start by drawing your unit circle, and let's focus in on quadrant 3. Here's pi, here's 3 pi over 2, so we know it's in between there. I'm going to draw a dot in between, going back to the origin, going back to the x-axis, creating that 90-degree angle, and identifying the central angle. Okay, again, this is a negative sign only because we're in quadrant 3, so forget about that negative sign for now. Sine is opposite, there's 4, over hypotenuse 5. I need to know what is this side. So a squared plus b squared equals c squared. A squared equals 25 minus 16. A squared equals 9. In general, when you solve an equation like this, you get plus or minus 3, but because we're talking about a length, we're only considering the positive value. Yes?
How do we know what goes in the A, B, and C?
A and B are always legs, and a hypotenuse is always the longest side, which is your C. So A and B always create the 90-degree angle. Okay? So we have secant and we have cosecant. All right, here's how I remember them. All right, so I know that S cannot go with S. So think of cosine before sine, okay? So S cannot go, secant cannot go with sine, it must go with cosine. So let's first figure out what is the cosine of this angle. Cosine is adjacent over hypotenuse. So the cosine is 3/5. Yes, it's not here. Give me 1 second. She's not here. Okay, so the cosine is 3/5. But when you find the secant, what do you have to do with the 3/5? You have to flip it. And then you have to ask yourself, the cosine in this quadrant is negative. That means its reciprocal is also negative. C cannot go with C. So cosine has to go with sine. What is the sine? Hey, we already told it's negative 4/5. Let's check. 4 divided by 5, opposite over hypotenuse. Okay, so I know this is 4/5. And then you flip it to get 5/4. And then keep in mind, in quadrant number 3, we have sign values that are negative. Thumbs up or thumbs down right now? Thumbs up or thumbs down? Okay, check really quick while I get for the next problem. Check with somebody around you that feels like maybe they understand it better or you can help that person. Let's go with 45 seconds. Go ahead. All right, here's your next one. You ready? At Trevor Brown, 52 students were randomly polled about the school lunch. 52 students were randomly polled about the student lunch. What is the margin of error? Remember, margin of error is plus or minus 1 divided by the square root of n. N represents how many people were surveyed or polled. So we can do 1 divided by square root of 52. We turn it into a percentage, and generally we round to the nearest tenth. So it's going to be plus or minus 13.9%. Remember, the more people you poll or interview, the smaller the margin of error. So do you agree that if you wanted to have an accurate poll, you had a survey, and you wanted to get results back, do you agree the more people you ask, the more realistically your answers will reflect the general population?
Yeah.
So the more people you ask, the smaller the margin of error. That means if I would have changed this from 52 to like 502, this number would have drastically gone down. Okay, so here's your next one. Let's talk this time about, let's say we are at Costco. And Costco has some type of a product. I don't know what type of food product here.
Let's say pickles.
Let's say rice. I'm just thinking about the heaviness of things. Okay, because it has to come in a sack. Okay, got it? And you are told that the average sack here of this particular product is 10 pounds. But there is a standard deviation of half of a pound. I want to know, consider that what we're about to do could be considered normally distributed, which means we have this shape, like a bell curve. We know 10 is the average. Remember, this is 1 standard deviation above, 2 and 3, 1 standard deviation below, 2 and 3. Okay, I want to know what percentage of bags, by the way, what did I just say? Bags. Say it right. That's right, it's the only way you're going to pass this class. How do you say it, Niley? No, it's not bag. Bags. Bags.
Why do you say it like that?
Why are you yelling at me? Issa, you just went from a C to a D.
Well, I don't have a... Wait, Liz, are you...
You haven't checked your grade lately.
You're supposed to... Miss, say it again, Miss,
Bags.
it's like pink bagels. Like bagels.
What do you, at lunchtime, what do you go play with Miguel? Tag. Like, where's Miguel? Where's Miguel?
What?
Yeah.
Egg.
Tag.
Oh, no.
I know. You'll learn. If not, you'll have me again next year. Okay, here we go. That'd be a blessing for you. Okay, here we go.
And you too, Miss.
Good comeback. So here we go. The average bag of rice is 10 pounds with a standard deviation of 0.5. We use the standard deviation from the average to count up. So 10, 10 and a half, 11, 11 and a half. Pretty easy to count, right? So this is where you determine, do you have to use a calculator or do you have to memorize the different intervals? So by the way, for memorizing, what goes to the right of this? 13.5, oh, thank you. 34, 34, 13.5, 13.5. Oh, what's the next one?
35.
Okay.
0.1.
Yep. Okay, so here we go. Find the percentage of bags with an average weight between 9.75 to 10.75. 9.75 to 10.75. So does that tell us we can just look at the graph right now and we can add up, or do we have to use a calculator? Okay, go ahead, please.
Can you repeat those numbers?
9.75 to 10.75. So if you've forgotten how to do this, because I cannot help you on the test day, you do second VARs, go to normal CDF, and then it's 4 numbers in a row. It's your smallest number. In this case, it is 9.75, comma, large number, 10.75, comma, the average, comma, and the standard deviation, end parenthesis. And we generally round this to the nearest tenth of a percent, which would be 62.5%. If I said to you, looking back here, if I said to you, what percentage of bags of rice are between 9 to 11 pounds? Figure out that number and do not say it out loud. 9 to 11 pounds. So here's your 9, here's your 11. You're adding them in between. And that is the middle 95th percentile, correct? It's your 95%. Okay, a z-score. Remember, we use standard deviation to measure z-scores. The z-score helps you know, are you considered statistically normal or abnormal, we could say, right? Those are simpler words. So here we go. Are you ready? Jesus, I'm going to use you as an example. right? I'm going to make this up. So in this class, the class average for the trigonometry test was a 74%. 74%, you're writing this down as the class average. Standard deviation was 10. 74% was the class average. Standard deviation was 10. And Jesus scores an 89. What is his z-score? Please don't say it out loud. Figure it out. 89. Now, would we consider his z-score to be a positive or a negative 1.5? Why? Because he's above the class average, okay? Because he's above class average, your z-score is anything above, in this case 74%, would be positive, anything below would be considered negative. Okay, here's the next one. Give me a second. These are going to be more beneficial to those that were here yesterday. If not, you may be a little bit lost. Okay, please write these numbers down. In this particular problem, you are asked to identify the sum of the geometric series that is shown. So with the geometric series, we can calculate the sum using this formula. So we know, we can see this is obvious, the first one is 3. The rate of change can always be calculated by taking the second number and dividing it by the first. 12 divided by 3 is 4. Let's check. 3 times 4 is 12. 12 times 4 is 48. Hey, that works. Let's put a 4 down. Now, the confusing part for students is, what do I put for n? So grab your calculator, please, everyone. And we're going to do this together. Remember, anytime you do something twice consecutively, 2 times in a row on your calculator, it will remember the pattern. So there's your first number. Take it times 4. Press enter. There's your second number. Take it times 4, press enter. So there's the first, second, and third terms so far in the series. Because I've done this pattern twice, I can now just press enter. There's 3, 4, 5, 6. Why do I stop now? That's the last number. Put a 6 right here. So we have 1 subtract 4 to the 6th power and press enter. Now, the most common mistake is students forget to use a parenthesis on the bottom. So divided by parenthesis, 1 subtract 4, and parenthesis, and now we're going to take it times the initial number of 3, and the sum of the first 6 digits, or the sum of the series shown, is 4,095. Okay, here's your next one. This goes back to, again, if you were here yesterday in class, this makes a lot more sense. Let's go with this one. Are you ready? You ready? Isui, you have a niece or nephew. Which one do you have, or do you have both? You do? Okay. So Isui tells her nephew, you know what? What's his name? Ethan. Okay, Ethan, I'm going to give you $1 on your first birthday. So we put $1 down. This works out perfect. Ethan is going to be a lucky boy. Hold on here. So I give $1 to Ethan on his first birthday, and then every birthday after that, I'm going to triple the amount. And I'll do that till he turns 12. And then after 12, I consider him kind of like an adolescent, like his parents can pick up the rest of the change, okay? Got it? So, Isui, do you agree that's reasonable?
Yes.
Okay. So what do you pay it for, or what do you give him on his second birthday? Okay, what about the third birthday? Okay, you ready? On your own, we're going to time this. You have 1 minute to calculate how much money has Ethan earned from his auntie Isui from just birthday collections after the first 12 years. Go. So if you're taking too much time, here's what you're going to do. How many birthdays are we adding up? 12, so put 12 here. What's the first amount? 1. How are we going from one number to the next each time? We're tripling it. How many birthdays again do we add up? The first 12. Calculate this on your calculator, please. Yeah, Ethan is set. You sweet? You're going to be in debt the rest of your life. That's a crazy amount of money, isn't it? And yet initially, like, I would have been like, easily like, yeah, I can do that. That triple the amount every time. What? That's a good bet, Ethan. I like it. Okay, does anybody have questions how we came up with that amount? I can go over it slower. Yes?
Sorry, the R is the like change?
R is, yes, the rate of change. How do you go up from one number to the next? Okay, here's your next one. I'm going to read this one out loud. Actually, maybe I can pull, no, you can't. Yeah, I can pull this up here. We're going to look at problem 10. You have not taken care of these type of problems or practices probably, except for the AZ merit practice dating back to the end of January or beginning of February. And this seems to be taking quite a long time, so I'm going to read it out loud to you. Here we go. You ready? Please write down only the basics of this. So we're talking about a radioactive isotope, and we know it decays exponentially. It has a half-life of 8 hours. It has a half-life of 8 hours. If after 48 hours there is 0.255 milligrams left, what was the isotope's initial mass? So we know it has a half-life. That's your rate of change. How often does that occur? Every 8 hours. The number in front of this should be the initial amount. And this amount is the total amount after a certain number of hours. Well, we're told for this problem, we're asked after 48 hours, we're told after 48 hours, the isotope has a mass of 0.255 milligrams. What is the initial amount? So how do we get that? Grab your calculator. Let's plug in 0.5, or you could put 1/2 in parentheses, and let's raise it to, we could put in parentheses 48 over 8. Hopefully you know that's also 6. So this is the amount right now that I have on this side. So I'm going to be lazy right now. I have 0.255 equals the initial amount times what I see on my calculator. Now if I want to isolate the a sub 1, which represents the initial amount, I want to divide by what I see on my calculator. So let's type in 0.255 divided by the previous answer, and the initial mass of the isotope is 16.32 milligrams. Let's do a quick review right now of exponential decay and growth. So let me just use some random numbers here. If something is exponentially grows, what can you tell me about the A? It is always positive. What can you tell me about the B? It is always greater than 1. If something is exponential decay, what can you tell me about the A? It is always positive. But the B, if it's exponential decay, the B is between 0 and 1. Not equal to 0, not equal to 1. It's in between them. Okay, here's your last one. Similar to the ESWI problem with Ethan. Aldo gets lucky. He puts his name into a hat and he happens to win the prize. And the prize is this. He doesn't have to do anything for this, okay? He's told on the very first day he makes $500. He doesn't have to do anything. He won this prize. First day is $500. Each day after that point, he makes 45% of the previous day's earning. So can everybody take 500 times 0.45 just so we have an idea what Aldo's bringing in? Whoa, whoa, whoa. 0.45. Did I say the wrong number? I'll repeat that in case I said something wrong. You start with 500 on day 1, 45% of that on day 2 gives you this amount. This would be day 3 and so on. Now he is going to continue to receive a payment until his payment goes below $1. At that point, we stop. My question is, on what date does he not receive a payment? And then if you add up all the payments, how much did he earn? Let's do it together. Can everybody do this with me, please? Type in 500. We know that's day 1. Take it times 0.45. This is day 2. Take it times 0.45 one more time, so we've done this action twice. The calculator again is going to remember this. So there's day 1, 2, and 3. Day 4, 5, 6, 7, 8. Does he get a payment on day 9? Why? Okay, so on day 9, there is no payment. Day 9, no payment. And we want to add up all the payments. We want to add up 1 through 8. So let's find the sum of the first 8. We start with 500. Our rate is 0.45, and we want to add up the first 8. Please calculate this amount. Approximately $907.56.